This video is about finding the local minimum and the local maximum of a function or of a curve. We're given a function f of x is equal to x plus 1 to be squared by 2 minus x, and x is a real number. You don't have to worry about this here. It's just telling you that it's any number can go into x here. So the first thing it asks us to do is write f of x in the form of ax cubed plus bx squared plus cx plus d. So they want us to expand this here. So let's do that. So firstly, I expanded x plus 1, and I expanded that to give me x squared plus 2x plus 1. If you don't know that, you need to go and find that out. There's other videos and help available for that. Next, I need to multiply it by 2 minus x. I multiply everything by the 2, and then I multiply everything by the minus x. So let's do that. Okay, so the 2x squared plus 4x plus 2, that's all multiplied by the 2. Then the minus x, I'm going to have minus x cubed. I'm going to have minus 2x squared and minus x, the minus x by plus 1. I collate all those together. I'm going to get a minus x cubed. I have a plus 2x squared and a minus 2x squared. They cancel each other out. I'm going to go 0x squared. The reason I'm doing that is because it does ask me to write it in this form here. So I might as well put 0x squared in. How many x's do I have? 4x minus x is plus 3x. And I have a plus 2. So there's my function. I'll just give it a nice title. Okay, so done. Part 2. Now find the coordinates, the local minimum point and the local maximum point on the curve. So just to remind you, we have a little curve, looks something like this maybe. As you can see, the slopes here are, that's a positive slope. That's a negative slope. This is a positive slope as well. That's a negative slope. But at this point here, what I'll do in maybe blue, this point, the slope is equal to 0. And as you can see, a slope of 0 indicates a kind of a minimum point and a maximum point. So we get the derivative and we let it equal to 0. So let's do that. F prime x is equal to minus 3x squared, that's 0, plus 3. Okay, I let this equal to 0. Let minus 3x squared plus 3 equal 0. That means that minus 3x squared is equal to minus 3. And that means that divide across by minus 3, x squared is equal to 1. X is equal to plus or minus 1. So I can get this, because it's equals on both sides, I can get rid of that. I divide by 3, gives me this, so plus or minus 1. Now, this is your minus 1 value, this is your plus 1 value. That's what it's telling me. It's told me where these are. But I want to find these values here, the ones I'm putting an x on now. So I substitute these values, minus 1 and plus 1, into my original function, which is here. So I'll copy this down here, and I'm going to stick in my values now. So x is equal to 1. Okay, I'm going to go that my y is equal to minus 1 to be cubed. I'm going to leave it to 0, plus 3 by 1, plus 2. And 3 ones and 2 is 5. This is a minus 1, so that's equal to 4. So my point is equal to 1, 4. Now the other value I have to sub in is x equal to minus 1. I'm going to give me y is equal to minus 1 to be cubed, plus 3 by minus 1, plus 2. That's going to give me minus 1 to be cubed is minus 1. Multiply by the minus gives me plus 1. 3 by minus 1 is minus 3, plus 2. So 1 and 2 is 3 minus 3 is equal to 0. So this point is equal to minus 1 comma 0. So I've got a minus 1, 0 there, and I have a 1, 4 here. So this is the max, and this is the min, as you can see. So it's going to look something like this. Okay. Oops, sorry, that's supposed to come down here. Right. Do better than that. This way here. Something like that. Okay. Good. Now you don't have to draw this here. I'm just doing this for you now to sort of give you an idea of what these points mean. So the answer is that our local minimum is equal to minus 1, 0, and our local maximum is equal to 1, 4. Okay, you can prove that, but we don't need to do that at this stage. Find the coordinates of the point where the curve intersects the x-axis and the y-axis. So part 3. We're going to find the x and the y-intercepts. So effectively what we're trying to find is, do it in red, what we're effectively trying to find is this point here, this point out here, and this point. We know what this one is. That's equal to minus 1, 0. Okay, so let's do that. Now, to get the y-intercept, this is the y-axis, I let x equal 0 because x is equal to 0 here. So I stick 0 into the function, and I'm going to get y is equal to, so now let's stick a 0 into that, and we're going to see it's going to give us y is equal to 0 plus 0 plus 3 times 0 is 0 plus 2. So 2. So the y-intercept is 0, 2. So that's what this point here is. This point is 0, 2. Okay, now let's get the x-intercepts. There's a hint here. I'm going to take this function down now the way it's written originally, because this is going to help us. Control V. Now, in order to get the x-intercepts, I want to get the x-intercepts, i.e. y is now equal to 0. On my function, this here, in order to get these points, the y value is 0 because we don't go up or down. So the y value is equal to 0. So we say now let y equal 0. That means that x plus 1 to be squared by 2 minus x is equal to 0. And that means we have two possibilities. We mean that this here, x plus 1, that has to be equal to 0, or this has to be 0. Because if I have two numbers, a multiplied by b is equal to 0, this one must be 0, or this one must be 0. One of them must be. So that means that x plus 1 is equal to 0, or 2 minus x is equal to 0. This means that x is equal to minus 1, or if I bring my x over to the other side, I'm going to get x equals 2x. So there's my two values. So the x-intercepts are minus 1, 0 and 2, 0. Now we already knew minus 1, 0 because look, you see we knew that one already, but we've now got another one. So we have the minimum point, the maximum point, and the x and y intercepts. Draw a rough sketch of the curve. Okay. Because I can't just glance up a page, I decided to write them all down here so you can see them at the same time. Our minimum is equal to minus 1, 0. So I might as well do a decent sketch this time. We'll see. I'll just mark this off in red. Okay, so minus 1, 0 is there. 1, 4 is there. Now you really don't have to be very precise with this at all. Our y-intercept is 0, 2, so that's going to be here. We know this is a minimum, that's a maximum. We have a minus 1, 0 is our x-intercept, and we have a 2, 0 here. Okay, so pencil, I would suggest. I would kind of definitely do this in a pencil. I'm going to be getting something like this here. Okay, and actually that's kind of rubbish. It would kind of look like this because it's going to have to kind of come out from that a little bit there. And let's go down through here. And be careful you start turning, and then it goes up there. So that's a quick draft, a quick sketch of our graph. And now finally, the last thing is, hence write down the range of values for which f of x is increasing. Okay, so the final section is, where is f of x increasing? So, for f of x is increasing. Let's do it in blue. Well, it's increasing here. There. It's not increasing exactly at the red dot, and it's not increasing exactly this red dot. So x is increasing between x, I'll do it back in yellow. Okay, x is greater than minus 1, and it's less than 1. So there are the values for f of x increasing. So I hope that helped.